In this video, we'll be introducing our RAG evaluation toolkit. Please feel free to check out some of our other videos for more information about Retrieval Augmented Generation and how dial RAG works. For now, we'll focus on assessing the quality of the retrieval part of RAG because it is more quantifiable. Was the RAG implementation able to find all the contexts containing the necessary facts? Essentially, if a RAG algorithm doesn't find the correct facts in the retrieved context, the model may still get a correct answer only by luck. We will discuss evaluation of the generation part in a subsequent video. Let's begin by looking at the three distinct tools in our RAG evaluation toolkit. Each can stand alone or work together. First, we have the log collection tool. This takes raw logs from all our components and parses them, providing as output usable Parquet files, which are split up per model or application. These logs contain all information about prompts, responses, the models used, logs from the underlying components, in our case RAG, and feedback from the user, like the thumbs up or thumbs down. You'll see why all this is important shortly. Second, we have our evaluation library. This library generates several metrics comparing model or application's results for a predefined set of questions with the expected results for those questions, which we call the ground truth. The library is distributed as Python package with a convenient API that can be used inside your application, your CI/CD pipeline, or run manually via CLI or Jupyter Notebook on a developer's machine. What exactly is the ground truth and how do we establish it? For any question or set of questions we want to evaluate, we need to define the set of facts that need to be contained in the retrieved context to call it a successful retrieval. Each question must have one or more facts that need to be found. There are a few ways to create this truth. We can create this set of facts fully manually from the UI, or we can ask an LLM to generate them based on very specific guidance and verify these as a human. Another option is to combine the manual feedback mentioned earlier from the logs with analysis of user sentiment about those responses. The technical methodology of creating valid ground truths is a bit outside the scope of this video, but these are the main techniques that can be used to generate them. This brings us to our third tool in the toolkit, the evaluation UI. The first tab allows you to import or edit the ground truth for a set of questions. The second tab shows an implementation's answers for the set of questions. Once we have the answers in the ground truth, the evaluation tab shows the results of our evaluation library, with the metrics about how effectively a certain RAG library retrieves context from a document or dataset. There are a few metrics, but the most important one for us is called recall. Basically, for any given question, there is at least one required fact. If the retrieval step of the application found at least one context for every required fact, we mark that as a success for recall. For example, suppose we have 3 ground truth facts for a question, and RAG finds 5 chunks of context for that prompt. Context 1 contains fact 1, context 3 contains fact 2, and fact 3 is not contained in any of the contexts. This is considered a recall score of 0.67 because 2 of the 3 facts were contained in the retrieved context. For the evaluation UI, you can see exactly which context corresponded to the ground truth. It is also interesting to note that our RAG evaluation toolkit is agnostic to the pre-processing methodology of how the contexts or chunks were generated. As long as the contexts are present, we can evaluate their quality. There are a few additional metrics, but the one we focus on most for evaluation is recall. Finally, we have the comparison and pair comparison tabs that allow users to visualize and analyze how applications performed over a set of questions. We can also track historical progress of some implementations and show visualizations like heat maps or historical line charts. One of the key takeaways we have found is that building applications for specific purposes and optimizing embeddings and prompts to handle this specific purpose, for example, searching a 10K form, will almost always be more effective than relying on generic, one-size-fits-all RAG solutions. Thank you.